stating this, that why it is you have to use in this case the processes. In other words, that why it occurs. Right, the displayed. Sorry, I don't think you caught the bit over here. Now, the displayed formula of 2,3,3,3,3 tetrafluoropropene. Again, 3 carbon, yep. On the second position, fluorine. On the third positions as well. Carbon is tetravalent, so it should have formed something on the lines of that. Okay, I've drawn the double chain here, but you can also draw the double chain here as long as you name the carbon chain. As long as you name it, otherwise it won't be counted. You should name the chain. Okay? Give one reason why 2,3,3 tetrafluoropropene is more environmentally acceptable than the chloro-difluoromethane. Now, why? This is a bit of a interesting one now, because if you remember talking in the topic about, if you to jog your memory, studying, did you study about freons by any chance, on how they possess the CF bond, which is not as harmful as the CF-CCl bond, and there's no breakage of the CCl bond observed? Yeah, that's what you have to write about technically. That's what they're wanting in the exam, to write about that. You have to remember, as soon as this, why is it more environmentally friendly? If they give the fluorine, you have to remember, yes, freons. Why? Because it doesn't contain the chlorine atom. There's a CCl bond. It doesn't produce the C free radical. It does not doesn't lead to the breakage of the bond, as I said, but also that the CCF bond, this is a stronger bond than the CCl bond. So therefore you can say this doesn't readily break actually. This doesn't readily break respectively. Moving on to our second one, that the refrigerator R410A. Again, refrigerant, thinking of our CFC, or they can say the freon. In this case, they're most probably talking about the CFC. Now, they've asked you, this is the again, you have to start extracting the important information. The ethane and the difluoromethane. Now, mechanism for reaction of fluorine with either alkane or fluoroalkane is similar to the reaction of chlorine with methane. Now, they said reaction of... So basically, normally in these type of questions, they will ask you to write the type of mechanism. As we know the type of mechanism, the free radical substitution. And that would give you your mark. Basically, it says that, again, one of our... we did come across similar questions. Remember, we have to... This is our... They'll always ask you in these type of questions, after they say the type of mechanism, they will ask you to basically state the steps. Now, you really want to revise this well. The initiation step, as I taught you, should be something like that. Then okay, and then you need something like that. You shouldn't forget this now, because it's quite simple, I would think. It's just you doing that extra effort of constantly, revising it again and again and again. And you would get your mark if you did this. Now, the termination step. 2 molecules of our CH2F2. This would lead to our CF2F, CF2F. You have to be careful in picking the termination step. Normally we use this molecule, which is used in our termination step. Now it says write the overall equation for the reaction of fluorine with ethene to form pentachloroethane. Again, very simple reaction. CH3CH2 with the reaction of our fluorine should give us the CH3CH2F2 plus our this should be our HF respectively. As you can see in this case, they've balanced it. You have to normally see the balanced equation part as well. Now they've given us IUPAC naming as well. You have to be very good with your IUPAC naming now. So first of all, we'll draw out the structure. Now, naming this, it will be 2, so it will be 1, 2, 2, 2, tetrachloro, 2 difluoroethane. So it will be 1, it will be 1, 2, 2, and then it will be tetrachloro, you can say 1, 1 difluoro, or sorry, 2, 2. So be 1, 1, 1. So be 1, 1, 1, 2 tetrachloro, 2, 2 difluoroethane. Obviously, our chlorine based on the nomenclature, should be named first. First numbering should occur from here, respectively. Now, nitrogen monoxide NO catalyzes the decomposition of ozone to oxygen. Write the overall decomposition of equation for its decomposition. Now, this is very, very important. NO decomposing to form, but again, you got confused in this. They've asked for the decomposition of ozone. This is where people get confused. They start writing decomposition of NO. No, you need to start writing the decomposition of ozone to oxygen. This is what you have to do. Decomposition, don't jump to conclusion. You have to read this question, what it says. Now, this is where it shows us the overall equation to reduce step 3 in the following mechanism that shows how nitrogen monoxide catalyzes the decomposition. This is where we have to use our overall equation, as it were. But how again, this is our further, you can say, as a second propagation step on how similarly our O2 should be generated again, plus our NO respectively. This is a bit of a hard one, but if you were to follow it through, you would get it. Basically, it's just the same on all the reactions which we've been doing. Again, you've got one of your favorite ones that they've asked you to write about the initiation steps again, so we'll quickly go through this. Remember? And the final termination step, which can occur okay, relatively simple. Next question. Highlight the keywords. Decomposition of ozone. Name the type of reaction intermediate that acts as a catalyst for this reaction. For this, you need to know the reactive intermediate. Now, when I mean by intermediate, we automatically think it's actually the free radical. Why? Because catalyst, that's why you need to know in depth all the reaction. If you remember the termination step, it actually leads to the end product is actually a chlorine radical, showing that chlorine radical acts as a catalyst, and whereas it's precipitated at the end of the reaction. Therefore, the only reactive intermediate that acts as a catalyst can only be our chlorine free radical. Now, write the two equations to show how this intermediate is involved in as a catalyst in the decomposition of ozone. Again, you have to write how sorry. That's what they are looking for. Now, this would get, and you see 7 mark questions. There's technically a free question. Again, this is our a second part of this. So they're quite the only questions which you'll get in this based on this. So it's quite a favourite question, isn't it, of theirs? Now in this case, they'll try to trip you up by giving you another sort of like B2 and F3, but bearing in mind you don't have to move that F3, and that F3 is not going to go anywhere. It's just going to stay there. It's actually going to be added on at the end. If you just, if that would be slotted in the middle. Termination step, as I taught you, you have to use that product. Or I can write, okay, state 1 condition necessary for the initiation of this reaction, UV light. If you don't remember anything, remember high in the atmosphere happens in the stratosphere. What's in the stratosphere? UV light. High temperatures, approximately 400 degrees Celsius. Wow. Now the second question, they've asked you to draw a displayed formula. This jogs your memory right back to the amount of substance chapter, I think, on how they've asked you to represent the types of formulas. Basically, the displayed formula is possessing the carbon chains along with the hydrogens. So they've asked in this that to write the displayed formula. Well, since the Br's gone, we know that there has to be a free radical over here, so it'll just be that. Simple as that. In the upper, the second question now. In the upper atmosphere, it's likely that, okay, upper atmosphere. What comes in my mind already is the stratosphere, isn't it? They're talking about the stratosphere. We know what reaction comes in here, ozone depletion, isn't it? What is the reaction known as? It's the free radical substitution reaction. Immediately you start reading these questions, it has to start going in your mind. Yeah, they're all related to this. Why is it more likely for the CBrF3 to produce bromine atoms than it is for CCl3 to produce chlorine atoms? Well, it all comes down to the processes of the bond enthalpy. This is jogging your memory right back to the, I think it's the energetics chapter, which you would have done this in, that we talk about the CBr versus CC. As we know, if you remember back from the group 7 elements, fluorine, chlorine, bromine, iodine, acetylene. Obviously, acetylene being radioactive, we don't really use that. But if you can notice that as you go down, the size increases, the atomic radius, as it were, increases. So therefore, the actual ionization energy would decrease. So ionization energy decreases in this case, resulting in the actual Br readily having a low bond enthalpy to undergo the reaction. Basically, maybe the UV frequency may be more favorable to the CBr bond as breakage rather than the CCl bond. So this would give you a mark. And this is for 1 mark. So basically 1 mark. To get that nice mark, you just give reference to the bond enthalpy. Again, that the CBr has a less bond enthalpy as compared to the CCl bond. That would give you a straight mark. Now again, they've given you this reaction in front of you. Immediately you have to write how, and then they've given you bromine free radical. Right. This is where you have to start your free radical substitution methods. Leading to obviously the beginning on how the bromine okay. But on this case, this is the initiation reaction. But they're going to ask you the main processes, which are the 2 propagation process. In this case, how bromine atoms, you're going to start with the first and the second propagation steps. They're going to ask you that. So you have to be ready. You don't have to start from the initial, because they only have the 2 equations. We know that 2 equations involve the propagation, so we've already formed the Br radical. Okay? Right? Then, as you know, to form our very famous back to our free radical. Now basically, why is the explanation, why does it behave as a catalyst? We know as it doesn't, you see, that it doesn't appear in the overall equation. So you can say that bromine, BRO, cancels, doesn't it? So first of all, you'll get a mark by saying it doesn't appear in the overall reaction. Also, that you'll get it's regenerated. It's more of like a common sense thing, getting your head down and looking at the equation that on both sides. That's how you have to think actively in this case. As you can see, if I've got BRO on both sides, that means it's going to cancel out. So it's actually not involved in the actual overall, or it's not displayed in the overall reaction, doesn't appear out in the overall reaction. It's regenerated, as you can see. Also, it's unchanged at the end, which proves that it's a catalyst. Also, you can say that it has not been used up. That will all give you marks. Coming on to see, this is the 5th question that we've seen on this case. The initiation reactions. Okay, first propagation stage. We know CF3 and then our CF3 will react with our chlorine gas to form this molecule. If I want to put that in a little bit on the center, and then termination to produce our hexafluoroethane. This will lead to the production of this. Now, where they've used the word hexafluoro, this can confuse people. Hexa, you'll think, hang on, it's 6. But then if you read the ethane, they mean that actually it's just 6 fluorine atoms. Give one essential condition for this reaction. Think. What's the essential condition? UV light. Again, the condition, high temperature. If you give the temperature. Last question, they've said in some refrigeration systems, CHF3 is replaced by CCLHF because of the concerns about ozone depletion. Identify the species formed from CCLF3 that is responsible for the catalytic decomposition of ozone in the upper atmosphere. Write the overall decomposition of ozone to oxygen. Basically, we'll do that first because we know that that would have been stuck in your memory by now.